Alrighty, as usual, let me give a couple of minutes for everybody to come on in before we get started. Alrighty, I think we can go ahead and get started. So first, let me make sure, can everybody see the screen? The little paper whiteboard looking screen?
Yes.
Yes.
Perfect. So today, I'm going to go ahead and work some of the math review stuff. As we've been discussing, make sure we kind of have a nice mindset about what math is required, how to go about thinking about some of these processes, and maybe you will see or hear kind of a slightly different take or a slightly different way of going about doing some of this math than maybe you would have seen in a formal mathematics class. So first, we're going to deal with algebra. Obviously, the most important bit of math we're going to discuss, or we're going to need for this class. And with algebra, obviously, the big thing is the simple, basic algebraic equation. Given an equation which has a single unknown in it, can you solve for the value of that unknown? That's basically the fundamental thing that an equation is for. And so, for example, let's say we have an equation that looks something like this: 5x minus 2 equals 8. All right, so if this were a formal mathematics class, what they would say is, if I want to solve for the unknown x, basically what you want to do is get x by itself on one side of the equation. And once you do that, the equation will tell you what the answer is. X equals some number. So how do you go about doing it? Well, you look at your equation and you say, the x term I want to keep by itself. Anything added or subtracted to that term, I want to get rid of. I don't want it on that part of the equation. So I have that minus 2 sitting there. And so I have to get rid of it. Well, how do I get rid of the minus 2? Well, if I add 2, then obviously plus 2 minus 2 cancels out. And so I would be left with 5x on the left side of the equation. However, then, mathematically speaking, in order for this equation to hold, the original equation was true, but now the equation's not true. I just did something to one side. I added 2 out of nowhere. So to make sure the equation holds, I have to add 2 to the other side as well. So I would add 2 over here. And so 8 plus 2 gives me 10. Almost there. Now what do we have? A new equation that says 5x equals 10. I want to know what the value of x is. Same thing. I need to get rid of the 5. How do I get rid of the 5? Well, if I'm multiplying by 5, I divide by 5. Another way of saying I multiply by 1 over 5. It means the same thing. And so the 5s would cancel out. And so, of course, I'd get x on the left side of the equation. Perfect. However, because I did divide by 5 on the left, I must also divide by 5 on the right. So if I divide this side by 5, 10 divided by 5 gives me 2. And now I have the value of my unknown, x equals 2. So that is the formal mathematical way of handling an algebraic equation, which is perfectly fine. And in fact, that's exactly what you do. However, what I will hint to you is I, of course, doing physics all my life, and thus doing a lot of mathematics, I've grown past thinking about solving an equation like this, and I think about it slightly differently. Now, as I show you what I think, what the steps are in my mind, at first it may seem a very subtle difference. I don't know, you're just saying it's different, but you're doing the same things, and that's true. I will be doing the same steps, but what you will find is the way I think about what I'm doing, what steps I'm doing, will help make your life easier later on when you're dealing with equations that are not quite like this. So what do I do when I see this equation? So I'll do it over here on the right side. 5x minus 2 equals 8. Same equation. Now what do I do when I see this? I don't think about getting rid of the 2 by adding 2, and so plus 2 minus 2 cancel out, and then I have to do the same on the right that I do the left. I don't think about it that way. I still think about the fact that I want to get x by itself, and I want to get everything else on the other side of the equation, and that's the key. For me, algebra is not about doing these operations that cancel terms. Rather, I think about manipulating or moving things in the equation. So that minus 2 sitting there is bad because I just want x on the left side. I don't want all those other numbers. So for me, what I think is I want to get x on the left, and everything else, I move it to the other side of the equation. Physically move it over there. So how do I move it? Well, if I want to get this minus 2 over to the other side, the rule is when you move a term to the other side, if it's adding or subtracting, it changes sign. So for me, I'm saying get the 2 over to the other side. So now the left side is 5x, and the right side becomes 8 plus 2. Because the negative 2 turned into positive 2 when it went to the other side. I just moved it over there. And of course, we know 8 plus 2 is 10. Perfect. And so now I'm left with this 5x equals 10 business. And again, I don't like that 5. I want x by itself. So I want to move the 5 over to the other side to leave x alone. Well, if I'm multiplying by 5, in order to move it, I do the opposite thing, which is to divide it. So I'm going to move that 5 over, and it becomes x equals 10 divided by 5, which of course is 2. And so now again, we have the same answer. Obviously, we better get the same answer. But for me, this was about rearranging terms, moving numbers around in my equation to get the x by itself, and everything else goes on the other side. Now, again, I know, or at least I've heard from a lot of students when first looking at it in this way, there's no difference. You're just saying, you're just naming it something different. You're still adding 2 and then dividing by 5 on either method, which is true. But the reason I'm trying to get you to see algebra as the rearrangement of terms rather than doing these operations is because when you get to physics and you actually get equations you have to manipulate, you don't have numbers everywhere anymore. So instead, let's say we have the physics equation, the kinematics equation, x equals, Let me do it in black. X equals V naught times T plus 1/2 a T squared. That's one of our basic kinematics equations. We've seen it in physics 1. And let's say what I'm trying to do is calculate the value of the initial velocity, V naught. I want to know what is that. Well, now notice, yeah, there's a 1/2 there, but everything's a bunch of variables. They're not numbers anymore. And so if I want to solve this, I have to know how do I get the V naught alone. And if you think about the original formal mathematical way, this makes it a slightly bit weird to think about because he said, look, I want to get the V naught by itself. So here's a term over here, this 1/2 AT squared thing. I don't like it. I need to move. I need to get rid of it. So how do I get rid of it? Well, notice it's comprised of 3 different things. There's a 1/2, there's the A, and there's the T squared. So if I want to get rid of those things, well, do I subtract them over since they're added on this side? And so I subtract them to get rid of, so what I do, minus 1/2, and that cancels the 1/2. And then minus A cancels the A. Is that what I do? Or I notice, well, 1/2 times A times T squared, those things are being multiplied now. So am I dividing by A? Do I have to divide by the A and divide by the T? What is it I'm supposed to be doing? Which operation am I supposed to use here? And I found that sometimes this can be tricky for students when they're not very comfortable with the algebra. However, my method, or at least the method I've grown accustomed to in thinking about how to do this stuff in terms of moving things, it doesn't confuse me at all. I say, look, here's some term, 1/2 AT squared. Yes, it's comprised of 3 different numbers. However, if I were to know what those numbers are and I multiply them together, it's just one thing, 100 or whatever it is. I don't know what it is. So I'm adding whatever this stupid little number is. So I know if I want to get rid of it, I want to move it to the other side of the equation. I just move that whole thing over. So for me, I would say, well, if I'm going to move it over to the other side, it changes sign. So I still have the X, and now I have minus 1/2 AT squared comes over to the other side. And now what's left on the right is just the V naught times T. And now again, on the right side, I have the V naught, the thing I'm trying to solve for, but now it's multiplied by T. I don't like that. I want V naught by itself. So I want to move the T over to the other side. So I know that in order to move it, since it's multiplied here, I divide it over. So I'm left with V naught is whatever was over there already, X minus 1/2 AT squared. And now I divide it by T. I moved the T over to the other side. And now we see I have the answer. And this is where this kind of way of thinking about solving algebra problems becomes slightly more powerful, or at least makes it a little bit more intuitive. I'm literally moving terms around in my equation to get, at the end of the day, the unknown by itself, and everything else is on the right side or the left side, however you want to do it. And so to me, if you start getting into this mindset when doing algebra, things become more clear and you make less mistakes about, was I supposed to have subtracted it over or divided it over, and things like that. So that's basic algebra. This is how you want to go about solving algebraic equations. You have an unknown, a single unknown in your equation with a whole bunch of numbers or variables everywhere. You rearrange the equation to get your unknown by itself and everything else on the other side. At this point, if this were a real problem, I would read the problem, and the problem would give me the data for what numbers to plug into these variables. I would know the time, I would know the acceleration, and so on. I'd plug them in, put it in my calculator, get an answer. However, that's only one part of algebra. That's the normal basic algebra. We can get more complicated versions of algebraic equations. For instance, the big one is written in this equation I already wrote. Let's write it again. X equals v naught t plus 1/2 at squared. Let's say instead, this time, the problem is asking us to find time, the t. Well, now this is a little awkward because notice t appears twice in my equation. And not only does it appear twice, but one of them has the power raised to this, it's raised to the second power, it's squared. Well, now all of a sudden, this is not a simple basic algebra problem, relatively speaking. Rather, this is what's called a quadratic equation because mathematics, they call a term which is raised to the second power, they call that quadratic. And so what we need to do is figure out how can we go about solving an algebraic equation which is quadratic. There's two ways you learn how to do this in mathematics. The first way is called factoring. And so you may get something that looks like this. X squared plus 2x, let's say, what is it, plus 1 equals 0. All right, basic quadratic equation, and you want to be able to factor it. And so what you usually do in math course, they'll say, okay, make this two binomials multiplied by each other, an x here and an x here, and maybe there's a plus 1 and a plus 1. Does that work? So we would multiply it out, use the FOIL method or whatever method you learn, and you find out that this thing is the same as that thing. And then we know that if this x plus 1 means that the answer is minus 1, and this x plus 1 says the answer is minus 1. So I find my answer is factoring. However, what I will say is in physics, don't even try to factor when you have a quadratic equation like this, because math courses particularly give you problems where the numbers are nice and neat and you can factor them. However, in the real world, when we're talking about actual problems, the numbers are not nice and neat, like 2 and 1 and 4. You get decimals and fractions and all sorts of weird stuff. So it's very rare that you'll ever have a quadratic equation that you can factor with a real world problem. So don't even try it. Instead, the main method that we use to solve a quadratic equation goes like this. We have a formula. That formula is called the quadratic formula. And if you follow it, you plug the numbers in appropriately, you get the answer. However, in order to do it, the first step is you must rewrite whatever quadratic equation you have into what's called the standard form. And a standard form looks like this: ax squared plus b times x plus c is equal to 0. Where x, of course, is the unknown, the thing you're trying to find, and a, b, and c are just numbers. And then, of course, on the other side of the equation is 0. So no matter what quadratic equation you have, the first step to be able to solve it is you must first rewrite it to look like this. So we look at our particular equation. It obviously doesn't look like that. We do have the t squared. Remember, t and x, it's just a name. So in this case, we're calling it t. We have a t squared, we have a t. But on the other side of the equation, it's not equal to 0, it's equal to a number, x, whatever x is. So the first thing we want to do is bring the x over and rewrite it in this standard form. So what do I have? Well, the t squared term, there's 1/2 a times t squared. And then we have plus v naught times t. And then when we bring the x over to the other side, it becomes negative. So we have minus x is equal to 0. And now we see that indeed we've rewritten our quadratic equation into standard form. This thing right here in front of the t squared, that's our a. The thing in front of the t, that's our b. And then the constant term, the thing that does not have a t on it, this thing is our c. And notice I circled the negative sign with it because the standard form shows pluses here. So if our signs are negatives, we have to keep track of the negatives. Negative is a part of the number. All right, so now I have my equation in standard form. What's the next step? The next step is the quadratic formula, x. The value of x, the actual answer, is minus b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. That's a quadratic formula. So once you've rewritten your equation into standard form, just pluck those a, b's, and c's out and plug them into this formula. You now have a bunch of numbers everywhere. Plug it into your calculator, you get an answer. In fact, you get two answers. You get two answers because right here, there's a plus or minus. So this actually means two different formulas. One formula, you use the plus. Everything's the same, but there's a plus there, and you get a number. That's one of your answers. Then you redo it all over again, but instead of a plus there, you put the negative sign. And so you get some other answer. And indeed, you should get two answers because if you remember in math class, they say that whatever the value of the highest power for your unknown, whatever that number is, that's the number of answers you're going to get. So for our unknown t here, the highest power is 2. So we're going to get two answers. If that were a t to the 4th power, then we're going to get 4 answers. But here it's 2. We get 2 answers. And indeed, we should because of the plus or minus. That's perfect. So let's try it. Let's try it with this particular equation. Obviously, I don't know numbers yet, but I could still do this. So I say, all right, t, that's the thing I'm looking for, is going to be equal to minus b. Well, what's my b? V naught. So minus v naught. Then I have plus or minus the square root of b squared, which is v naught squared, minus 4 times a. What is a? 1/2 a. Times c. C is negative x. Remember, the negative is important here. You got to keep track of those. And all of these things are divided by 2 times a, and a happens to be 1/2 a. And there we go. If this were a real problem, I would have the value of all these things. The problem would tell me the initial velocity of the rock was 20 meters per second. So I'd put 20 for V naught. Acceleration due to gravity is 9.8. So A would be 9.8. The distance the rock falls is 10 meters. So X would be 10, and so on. I plug all those things in and I get two separate answers. T is equals to blah, 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 and T equals to blah, blah, blah. My two answers. And that's how you solve a quadratic equation. It's obviously much more of a pain in the butt than normal simple algebra, where you have one single unknown and you just rearrange it. But the good news is, no matter what quadratic equation you have, in terms of real world problems, you will always get the answer if you use quadratic formula. Obviously, yeah, what's up?
I just wanted to get clarification. Can you remind me or reteach me real quick again on when do I use a plus or minus? When would I use a plus or minus when I'm trying to use the quadratic formula?
Yeah, so the plus or minus is built into the quadratic formula. So it's always going to be plus or minus. Now, when you actually want to get an answer, and so let's say if I were going to do this in a real problem, let's say the problem told me V naught is 20, A is 9.8, and C, not C, X, the value of X is 10. So we're doing a real physics problem. It gives us the actual values of these things. So for me, what I would do is I'd plug them in. I'd say, all right, minus V naught is minus 20 plus or minus square root of 20 squared minus 4 times 1/2 of A, and A is 9.8, times C, which is minus 10, all divided by 2 times 1/2 of 9.8. All right. So what would I do to actually get this number? The plus or minus is always there. So really, I should write this twice. Once I'll do it for a plus. So I'll say, okay, minus 20 plus square root of 20 squared minus 4 times 1/2 of 9.8 is 4.9. I'll just put the number down. Times negative 10. All divided by, notice the 2 and the 1/2 cancel. And so there's just a 9.8 down here. Okay. And if I were to get my calculator out, I'd plug all these numbers in. Bam, I'd have a number for that one. But that's only the plus one. So now I have to redo it again, this time using the minus sign. Same exact thing, negative 20 minus the square root of 20 squared minus 4 times 4.9 times negative 10, all divided by 9.8. Okay, and again, I stick these numbers into my calculator, be careful with it, and I get some other number. And so now I have two answers. And in mathematics, two answers is perfectly fine. T can be 3.5 or it could be negative 18, whatever the answers are. So that's what this plus or minus is. You always have plus or minus here. It's just built into the formula. And what it tells you is do this thing twice. Do it once where it's a plus sign. I better not put an underline. It looks like a negative. Do it once where it's a plus, and then separately do it again where there's a minus. So it's just a way of standing for, hey, do this two different times, one with a plus, one with a minus, and they just call it plus or minus. Now in physics, by the way, if this were a real problem, the problem is something like you're on the top of a cliff and you shoot a cannonball off at an angle, whatever, and it lands some distance away. You want to know how long does it take for the ball to hit the ground? Well, obviously there's only one answer. Once you shot the cannonball, it takes some amount of time and it's going to hit. So why the heck do I get two answers here? Well, in physics, since we're not just mathematicians here, we're actually getting real world answers. One of the answers makes sense and the other one doesn't. For instance, one of them may be, 3.5, like I said, and the other one might be negative 18. Well, we know if what we're talking about here is time, there's no such thing as negative time. What that means is if I shoot a cannonball off the cliff, 18 seconds before I shot it is when it hits the ground. That doesn't make any sense. So that's worthless. It's good for a mathematician, but for us, we're realists. We say, no, it took 3.5 seconds to hit the ground. 3.5 seconds after you shot it, that's when it hits the ground. That makes sense. Negative time doesn't make sense. So to a physicist, we'd only keep one of the answers. But in terms of the mathematics, you have to do this thing twice. One gives you the plus sign there, the other gives you the negative sign there. Okay, so does that make sense?
Yes, sir. Yes, sir. It does.
It did.
Perfect, perfect. Okay. So, so that's our quadratic equation stuff. It is a pain in the butt, I admit. In fact, I'll be honest, what I usually do when I have a quadratic equation and I want to get an answer, I Google quadratic equation solver, and it just lets me put in the value of A, B, and C, and it gives me the answers. It's just easier. If you don't have access to the internet to do these things, then you physically have to put the numbers in and get your calculator out and calculate it, which is perfectly fine. But we all think it's a pain in the butt. I'm with you there, but it's doable. We have the method and it works for every single problem, which is nice because if you remember from high school algebra or college algebra, they'll give you, 25 different algebra problems you have to solve. And some of them you can factor. Some of them are easy to factor. Some are a little bit more complicated to factor. And some you can't factor at all. And they don't tell you which is which. So you're sitting there trying to factor stuff that maybe you can't even do. However, what makes the quadratic formula so nice is it always works. It never fails. So if you always use it, even though it's a pain in the butt to use, if you always use it, you'll always get an answer. And like I said, just in general, in an actual physics class where we're using fancy numbers, you're almost never going to be able to truly factor these quadratic equations like this. So don't even try it. Just go straight to quadratic formula. Now, with that said, what about if we had a different problem? Something very similar, though. What if instead we had something that looks like this? X squared plus 4x equals 0. I say, aha, okay. Well, notice the variable, the unknown variable here, x, the highest power is 2. So again, it's quadratic. So, oh man, I have to use quadratic formula. But here we don't have to use a quadratic formula. And notice why. In order to use the quadratic formula, the standard form has the x squared term, the x term, and then this other term, which is just a constant. It's a number. Here,
Professor,
yeah.
could you go up and so I can get a snapshot of the green? I wasn't finished writing. Thank
Yeah.
you. That's perfect right there.
Sure.
I got it. Thank you.
All righty, no problem. So notice here we have the x squared term and we have the x term, but we don't have that constant term, the plus c part. So, yeah, what's up?
I was gonna say in this situation, if in this situation, would you do x multiply x times and then you have parentheses x plus 4? I mean x plus 4. Would it be in that situation? Would you do that for this?
Very, very perfect. That's exactly what I would do. What I was actually about to say was because we don't have that plus c term, this thing we can factor. And the reason we can factor is because what makes factoring important is that there's something the same on every term. So because every single term, remember 0 doesn't count as a term in an equation. So there's only really 2 terms here. Each one of our terms has an x on it. So since there's an x on every single term, we could pull out an x as common. So I say, look, there's an x everywhere. So x times something. What's it times? Whatever's left over once you took the x out. So the first term was x squared. I took one of the x's away. So what's left is x. The second term is 4 times x. Well, I took the x out already. So all that's left is 4. So x plus 4. There we go. And in fact, if we were to multiply the x back through, we'd of course get back to that, which is what we started with. So in this case, we can factor. And remember, the right side still has the 0. Now, okay, good, we can factor it. But how in the world do I solve this problem? Because it's not necessarily straightforward how I would do this. There's x's in 2 different places. And what I like to do, what I like to show as a kind of a thought experiment is a different problem, which is to say, let's say we have this problem over here. Some number a times some number b is equal to 0. If I told you that that's true, that there's 2 numbers, a and b, and I multiply them together and I get the value of 0, what can you tell me about a and b?
Well, one must be 0 and the other must be a regular number.
That could be. What is definitely true is at least one of them has to be 0. Now they could both be 0. It could be 0 times 0 is 0. That's fine. But either the a is 0 or the b is 0. It has to be, because if you multiply 2 numbers, the only way to get a 0 is if one of them at least is 0. Perfect. Well, now look at what's in blue here. In blue, I have 2 different terms, the x. So either the x is 0, that's like the a, or this parentheses thing, which is like the b, must be 0. Or both. They could both be true. So one of these has to be true at least. So this tells me either x is equal to 0, which is one answer, or x plus 4 is equal to 0. And if that's true, well, this is a nice simple algebra problem. Bring the 4 over to the other side. So I get x is -4. That's my other answer. And there we go. I started with a problem. I better get 2 answers because remember the highest power there tells me how many answers I'm going to get. 2. I was able to factor because there's an x that's common to every single term. So I pulled it out. And now I'm set up with 2 terms, x and x plus 4. And I know that if I multiply those 2 things together to get 0, then either one or both must be 0. So this tells me either x is equal to 0 or x is equal to -4. Or both could be true, let's say. So now I could use the quadratic formula here if I wanted to. Now, it would be ridiculous to do it because this is quite easy. This is nice and straightforward. But what I could have said is this equation, x squared plus 4x plus 0 is equal to 0. And now we see the a term is 1, the b term is 4, and the c term is 0. And I could do quadratic formula with these 3, a, b, and c, and I'd get the same 2 answers. So yeah, I could use a quadratic formula still because technically this is a quadratic equation. It's just not standard form. I create standard form by forcing an extra 0 in there for my c, and I could go through the process of doing it. But why in the world do I want to go through that process if this is easier to do? At least to me it is. So be on the lookout for that. Just because you may see an x squared or a t squared in your equation doesn't necessarily mean you have to use quadratic formula. Check to see if it's something like this where it doesn't have that constant term. Likewise, another example similar would be something like this. 4x squared equals, let's say, 64. Okay. Or, and in fact, let me do it like this. 4x squared minus 64 is equal to 0. Okay, same thing. How would I go about solving this? Again, I have an x squared sitting there, so it looks kind of like it's quadratic, but notice I don't have that linear term, the term that just has an x by itself. How do I do this? This is a nice straightforward square root style of problem. So what I would do here is I'd say, look, bring the 64 over, bring the constant, the number over. So 4x squared equals 64 now. Move the 4 over to the other side because I want to get the x squared by itself. So x squared is 64 over 4. And what's 64 divided by 4? 4 into 6 is 1. 24, so that's 16. Okay. So now what am I left with? I'm left with x squared equals 16. And of course, we all know how to solve this. I don't want x squared. I just want x by itself. How do I get rid of the square? I take the square root. So this tells me, of course, x is equal to 4. The square root of 16. Now, you have to be careful because math tells us if you take a square root, then technically this means 2 different answers, plus or minus. And if you remember, there's our little x squared thing. I better get 2 answers. This is how I get 2 answers. One is positive 4. The other answer is -4. Okay, so again, we have an example of something that looks like a quadratic equation, but we don't actually have to use the quadratic formula because it doesn't have all 3 terms. It has a quadratic term and then the constant term, but it's missing the linear term, the thing with an x on it. I could use quadratic formula. Again, I could say, okay, well, this is 4x squared plus 0x minus 64 is equal to 0, and just call b equal to 0. I could do that and then use a quadratic formula. But again, I'd be wasting my time because that's more work than just doing the basic algebra of this form, where I could take a square root at the end and get rid of the square. Okay, so those are the 3 main basic algebraic ways of solving equations. We've got normal simple algebra, where you have one unknown raised to the first power, and you manipulate the equation to move things to the other side and get the x by itself. Then you have the quadratic stuff. One, the full quadratic equation, where you have the t squared term, the t term, and the constant term that does not have a t in it, in which case, get it into standard form, figure out what's your a, what's your b, what's your c, and then plug it into the quadratic formula. That gives you two answers. And if this is physics in a regular physics class, one of the answers is right, one of them you don't need. And usually it's fairly clear which one is the one we throw away. Or you can have these other ones that look quadratic, but we don't need to use the quadratic formula because it doesn't have all three terms. And so either we factor it or we just do a basic square root, whatever the case may be. Now, the last thing about algebra I want to go over is, and I always like that term because it's like the last thing I want to do means I don't want to do it. But in this case, I mean sequentially last. The last part of algebra is what happens when we have two equations with two unknowns, or what's called a system of equations, a linear system of equations. Well, there's certainly many ways of doing this, and I'll show you what I find to be the way that takes the least amount of thinking. Okay, once you know the rule, then you just crank the rule out and it gives you the answer eventually. And so let's say we have this problem. I don't know what the physics problem is, but at the end of the day, we have two equations and two unknowns. So let's say it's something like 2x plus t is equal to 5. And we also know x minus 4t is equal to -2. Okay. And so this is some problem where I need to find where the two things meet and at what time they meet. Something like that. So I'm looking for a distance and I'm looking for a time. Two unknowns. And it so happens that somehow I use two equations and I'm left with this. The question is, how do I go about solving for the two unknowns? And so what I'm going to use is what's called the substitution method. And what it says is this: the first step in the substitution method is choose one of the equations and solve for one of the two unknowns in that equation. Good news is it doesn't matter which one you choose. It doesn't matter which equation, and it doesn't matter which variable. Just pick one. Now, obviously, the art of doing this is to pick the one that's easiest to do because it makes it faster. It makes it easier to do. Why choose the one that's the most complicated? So when I look at this, I say, okay, well, I'm going to choose an equation where one of the variables is by itself. I don't have to manipulate all that much. So when I'm looking at it, I see, look, in the first equation, the t is sitting here all alone. All I'd have to do is bring the 2x to the other side. Or in the second equation, the x is all by himself, so I could bring the 4t over to the other side. So which one do I want to do? Doesn't matter. Let's say I choose the first one, just for the sake of doing it. So I'm going to choose the first equation. Here it is, 2x plus t is equal to 5, and I'm going to solve it for the t. So t is the thing I want. The x thing is just some number in my mind. So bring the 2x over to get t by itself. So t equals, the 5 is still here, and now when the 2x comes to the other side, it becomes negative, minus 2x. And there we go. Notice this is as far as I can go. I don't know the number. I don't know the answer for t. But if someone told me the value of x, if someone said, look, x is 3, then I could plug 3 in for x and I could get an answer for t. That's what I want. But I'm stuck. I can't go any further. So the second step, once I've picked an equation and solved for one of the two unknowns, I've done it. Second step, In the other equation, the one you did not use, everywhere you see the variable you just solved for, substitute in the thing the variable equals. So I use the first equation, so I have to move to the second. The second one is x minus 4 times t is equal to -2. However, this t, everywhere I see a t in my new equation, my second equation, I don't want to write t anymore. Instead, I'm going to write 5 minus 2x because the first equation told me that's what t is. So, okay, let's write it. X minus 4 times, well, instead of t, I write 5 minus 2x. Okay. And then I finish out the equation, equals -2. And now something magic just happened. Now all of a sudden I'm left here, right there. I have an equation that has only one unknown. No longer are there two unknowns in this equation. And math says I can solve an equation that has only one unknown in it. Perfect. So I could get an answer for x. So let's do it. So I'll bring it over here just to give me some room. And obviously it looks messy. So I'm going to try to simplify it down. I'm going to multiply the 4 through and get rid of the parentheses. So what do we have? We have x, and then we have -4 times 5 is -20. And then -4 times -2x. Well, minus becomes plus, so it's plus. 4 times 2x is 8x. Okay. So I've now distributed the -4 into my parentheses, and that's what's left, equals -2. This is a little nicer. I can see how to solve this. First thing I'm going to do is combine the x's together. So x plus 8x is 9x. -20 equals -2. All right, well, now all we have is a nice simple algebraic problem. I want the x by itself, so I'm going to move the 20 over. So 9x equals, when a 20 comes over, it becomes +20. So +20 minus 2 is +18. I want the x by itself, so I'm going to move the 9 over. So it becomes x equals 18 divided by 9, which is 2. I now know one of my answers. The value of x is 2. Perfect. But I still need my other answer. Remember, I wanted both things. I wanted x and t. But notice, now that I know what the value of x is, I go right back to this thing I had at the very beginning that said, if you tell me what x is, I can tell you what t is. Well, now I know what x is. So let's plug it in. 5 minus 2 times x, and x is 2. So 5 minus 2 times 2, 2 times 2 is 4. So 5 minus 4 gives me 1. So now I know t is equal to 1. And there we go. I have my two answers. And that's what substitution is. You start with an unsolvable problem, an equation that has two unknowns in it. Let's say just the first equation. You can't solve that. So what math says is, well, if you have an equation that has two unknowns, if you give me a second equation, I'll have a method to solve it. And so somehow in physics, we found a second equation and we used it, and that's equation 2. Unfortunately, he also has two unknowns. So I can't just solve him by himself either. So now I have a system of equations, two equations with two unknowns. For me, I use substitution method to do it, and this is it. First step, choose any one of the two equations you have and solve for one of the unknowns. That's going to leave you with x is equal to blah, blah, blah times t, or t is equal to blah, blah, blah times x. In this case, we solved it for t. And then we leave it alone. We say, all right, I know that information. Once someone tells me what the value of x is, I'll give you the t. So let's leave it there. And now we move to the second step. Once you found it, choose the other equation you did not use. And everywhere you see the variable you just solved for, substitute in the thing it's equal to. And what that does is it gets rid of that variable and leaves only the other variable there. So now you have an equation with one unknown. And now you just do whatever algebra is necessary to solve for the value of that unknown. Now you have one of your answers. In this case, x is equal to 2. The last step is, now that you know x, go back to that first step you just did, where you said t is equal to blah, blah, blah times x. Now plug in the value of x, and you get your answer for t. To me, this is the simplest way of doing this type of problem. There are other methods. I'm sure you've seen it in math class, and you may like those other methods. For instance, just quickly, I'll tell you, one way people do it is they would say, look, if I multiply this whole equation by 2, and then I subtract the two equations, that's going to cancel the x terms. And that'll leave me with t is equal to something. And then once you know that t, you plug that back into the first equation, you get the x. That works. The problem is, in order to do it, you first have to think and say, look, how do I manipulate these equations so that when I subtract them, something cancels out? I don't want to have to mess with that stuff. I want to do as little thinking as possible. I trust my math, but I don't trust my creativity in my brain. So instead, I know how to follow rules. Give me the equations, and let me just crank out the answers using the rules. I don't have to think about anything. I don't have to modify anything. I just let the math do the work, and it gives me the answers. That's how I do it. That's how I will always do it in this class. If you, on your homework or a test, use some of the other methods and you do it correctly, that's perfectly fine. But what you're going to find from me is using the substitution method every time. And I just find that it gives rise to the least number of mistakes. And that's all of algebra. So all of that is all the algebra you're going to need to be successful for this course. Now, what we're going to do Monday is go to the trigonometry stuff, which leads us to vectors. And with trigonometry, we're going to look at sine, cosine, tangent. If I know the angle and the hypotenuse, can I get the other two sides? All those little tricks with right triangles. And so I'll teach you that, how I do it, how I think about it and stuff, because that's necessary for when we talk about vectors. But in terms of the algebra, if you can do these things, then you're fine with algebra. All the other fancy algebraic techniques, we're not going to get into any of that stuff because it's just more than is necessary for our purposes. All right, so any questions? I know we've run over a couple of minutes. Are there any questions on any of this? All right, so that's all we have for today. On Canvas, you should have seen posted those previous last year's lecture videos on all of these math topics. Also, the practice problems and the solutions, all of that is posted. So it looks like a lot, but it's just I posted it all at once. Obviously, it's over these next couple, this week and next week is all the material there. So start practicing those problems. Try them out on a blank sheet of paper. Make sure you're understanding what's going on. And if you want to look at the previous lectures, feel free to look back at them as well. But Monday, we're going to move on to the trigonometry stuff. And then by the end of the week, in the next week, we'll actually start into the first topic of physics. Also, I will be posting a homework assignment on the math review stuff. And I'll email when that's done. But usually I give about a week to turn in the homework, so it won't be due till next Friday. But just know that when it's posted, I'll send you an email and you can start working on it whenever you want. And then lastly, now that you've seen kind of my method of how I do these online lectures and I use my iPad to do the whiteboard and stuff, you get a feel for if you like these online lectures or not. And so I will be posting that poll as we discuss these last 2 days to see what your thoughts are on if you like doing online lectures like this instead of having to come in, or if you'd rather go into class and do this in person. But again, next week, we're going to continue the online stuff just because we're continuing the math review stuff. So next week will be more online, but after that, it depends on your responses. All right, so I'm sorry we went over a little bit, but if you have no questions, you're free to go, and I will see you next week.
See you next week.
Thank you.
Did
Thank
you take roll at the beginning of the class?
Have a good day.
No, I didn't take any role. The Zoom thing, because it's recorded, takes track of who's here and who's not. So I have the role in that sense.
Okay, I was just making sure because my connection was unsteady at the beginning.
No problem. Yeah, I have you on here, so it's good.
Okay, all right. Have a good day.
You too.
Thank you.